As stated, I'm Mike Bartlett, and I'm here to briefly describe the Middle Road Bridge, which is a 16-foot wide, 80-foot long, reinforced concrete arch-truss bridge constructed, as Jacob correctly said, in 1909. This is actually the first bridge of this form constructed in Canada, and this past summer it was celebrated as a Canadian Society for Civil Engineering National Historic Site. In the next few minutes, we'll briefly introduce the bridge designers, the Toronto-based firm of Barber and Young, and review their perspectives about bridge aesthetics. We'll introduce the contractor, O.L. Hicks of Oakville, and describe some of the innovations in the construction. And we'll compare the Middle Road Bridge to some other bridges of the time, both steel trusses and concrete arches. And finally, we'll quickly visit the plaque wording and make some conclusions. This is a Google Earth satellite with Lake Ontario at the bottom, the city of Toronto on the right-hand side, and the city of Mississauga on the left-hand side. So people who fly into the Pearson International Airport may think that they're landing in Toronto. They're actually landing in Mississauga, just west of Toronto. And the arrow shows the location of the bridge crossing Etobicoke Creek, spanning between the city of Toronto on one side and Mississauga on the other. The bridge was designed by James Franklin Barber, principal of the firm Barber and Young. Barber was known as Frank and was born in Milton and attended Mount Allison University and the School of Practical Science at the University of Toronto, which became the Faculty of Applied Science and Engineering there later. He apprenticed under James McDougall, York County engineer, and assumed McDougall's consulting practice after McDougall's death in 1908. He subsequently was engineer for York and Haldimand counties and for York, Vaughan, and a number of other townships in the Toronto area. And in 1915, at age 40, he was an associate member of the Canadian Society of Civil Engineers. He was a prolific bridge designer. He designed over 200 bridges between 1909 and 1920. Some of the more well-known bridges he designed include the Ashburton Bridge in Peterborough, which was the longest concrete arch span in Canada when it was completed in 1921. And on the right, Sewell's Road Bridge, a very short span, single lane suspension bridge that was very cost effective. His partner was Clarence Richard Young, who was born in Picton and who also attended the School of Practical Science, though he subsequently earned an engineering degree from the University of Toronto. He spent a couple of years doing municipal drainage surveys and doing highway and railway bridge design. But then in 1907, he rejoined the University of Toronto as a part-time lecturer, then a professor. Then he became head of the civil engineering department. And finally, during the Second World War, he was the fourth dean of the Faculty of Engineering at U of T. He joined, I'll go backwards. He joined Barber's consulting practice in 1909, and by 1910, they designed at least 26 bridges and had overseen construction of 19 of them. Young was a proponent of aesthetic bridges, and in fact, in a 1911 lecture to the Toronto branch of the Canadian Society of Civil Engineers, he identified 3 causes of unaesthetic bridges. The first, he said, was adverse locations. The second was parsimoniousness on the part of the purchasing municipality. And the third was a general lack of good taste in the people and to some extent in engineers themselves. He proposed 10 principles for bridge engineers to make aesthetic bridges that included beauty coming chiefly from the general form and legitimate ornamentation. He said about aesthetics that the general form of a steel trusses, this is the photograph, is a through Pratt truss, which would have been by far the most common form of construction, bridge construction in Canada and the United States, probably at the turn of the last century. Young said, the general form of a steel truss is often decided with no thought of aesthetic design, and a few dollars afterwards spent on ornamental railings or other details will never remedy this defect. Instead, they said, mathematics and aesthetics go hand in hand. The aesthetic nature of bridges must, to a large extent, always be associated with mathematical analysis and a thorough knowledge of the properties of materials. As you can see from this 1909 photograph, this would have been taken just after the bridge construction was completed. The Middle Road Bridge is an arch truss with webbed diagonals to resist shear due to unsymmetric loadings. And so this allows the main arch members to be designed as simple two-force members without carrying bending. The design criteria were quite simple. A 10-ton vehicle on 2 axles, which incidentally confirms Kurt's 10,000-pound axle used for pavement design in 1918 that we heard about a little bit earlier today. Oh, but 2/3 on the rear axle and a distributed load of 100 pounds per square foot. They used a very liberal impact allowance of a half of the live load, probably because they recognized that much of the traffic on the bridge would be farming traffic, animals. And they used quite low allowable stresses. So the maximum compressive stress in the compression cord was 430 PSI for the concrete and about 6,500 PSI for the steel. The contractor for this bridge was Octavius Laing Hicks, who at the time was the most active and widely known bridge contractor around Toronto. He was based in Oakville, which is just west of Toronto, just west of Mississauga. To overcome local council's reluctance to construct a new bridge form, the Arch-Truss, from a new material, reinforced concrete, Hicks agreed to accept the price of the lowest tender for a steel bridge. So he got the job in a slightly funny way. He had other business interests, which included hotels, yacht and shipbuilding, commercial fishing fleet, and a brickyard. In 1880, he patented a sliding seat for racing sculls. And so here he's seen on the Humber River in 1904 in the foreground. The sculler behind him is Ned Hanlon, who was a world champion sculler from Toronto and a good friend of Hicks's. He also invented the Flotilla Merry-go-round. So here you get a sense of it. You paid your 5 cents and would climb into one of these boats and be towed around a circular course in a canal, essentially. Hicks came up with a couple of construction innovations. The first was an ingenious device that pre-tensioned the reinforcing steel rods in the tension cord before the concrete was placed to limit hair cracking under the full service load. This is an early application of pre-stressing, really. It probably wouldn't have been particularly durable given what we now know about long-term losses due to concrete shrinkage and creep, and due to steel relaxation. And he laid bags of ice on the last concrete placed at night. The concrete was placed in a 6-day period working dawn till dusk. So every night the workers placed these bags of ice on the last concrete placed to prevent the newly placed concrete from setting at the joint locations. And Barber and Young say in their 1909 paper that this procedure was very effective. The next morning, the concrete was, quote, perfectly plastic as if it had just been poured. So this photograph was probably taken on the official opening of the bridge on October 27th, 1909. You can see from the animal droppings on the deck that the bridge has probably been in service since September of that year. They carried out structural proof tests as part of the official opening. And there was another accidental load test when a herd of Alderman John Dunn's cattle, which had come to the river to drink, were driven onto the bridge. Barber and Young claim in their 1909 paper that the weight of the cattle was probably 35 tons, and the vibration under these loads was very slight. So Barber and Young say that their bridge is the second Arch-Truss constructed in North America, and recognize the approaches of the Speakman Street Bridge, which opened a month earlier in 1909, to be the first. The Speakman Street arches are kind of hidden by the verticals, and because the bridge is a deck arch, not a through arch, the user on the deck wouldn't see the arches very easily. It's interesting that the 1998 Historic American Engineering Record Report on the bridge does not include commentary or photographs about the concrete arches, but it does mention that the design was questioned. The designer, Howard M. Jones, acknowledged a lack of accurate knowledge of the distribution of stresses due to eccentric loadings, and actually paid for a 1 in 10 scale model of the bridge to be built and tested to demonstrate its strength. The concern here, of course, is that this has to work as a Vierendeel truss to carry shear due to load on one half of the span and not the other half. So let's find out. The plaque, which is underway, will say that the Middle Road Bridge, constructed in 1909 primarily to carry farming traffic, was the first reinforced arch-truss bridge in North America. The Toronto-based firm of Barber and Young designed the structure following the principle that mathematics and aesthetics go hand in hand. James Franklin Barber was a very prominent bridge designer of over 200 bridges in Ontario between 1908 and 1920. Clarence Richard Young joined the Department of Civil Engineering at the U of T in 1907. And the builder, Octavius Laing Hicks, was a widely known bridge contractor around Toronto. Here's a proof of the plaque. The plaque is currently being manufactured, and we hope to have it installed before the cold weather hits, which is a window that's approaching rapidly. And this is fun. We've also discovered that the profile of the bridge has been used as part of the logo for the City of Mississauga's Heritage Advisory Committee. So the Middle Road Bridge is a very worthy CSCE civil engineering historic site. Thanks for your attention, and I look forward to trying to answer any questions you may have. So I'm going to stop sharing right there.
Mike, there's one question that asks, what type of repairs have been done over the years?
So that's a great question. And the repairs are repairs that are pretty typical to this form of construction, which are essentially to remove deteriorated and spalled concrete, to touch up reinforcing steel that may have corroded slightly, and then to reconstruct the bridge to the original finish. One of the good things about this bridge is that it was actually taken out of active roadway service in 1932. So it had about a 12 or 13 year period of time when it was carrying traffic. And when it became a pedestrian only bridge, then the use of road salt as de-icer would have been markedly reduced. So the bridge is actually in quite good condition for a structure that's over 100 years old.
One of the other questions was, are there any issues with ASR?
Yeah, Brian. So the short answer is I don't know. I don't think so. The aggregates in Ontario especially central Ontario, are pretty good for ASR. You get into the eastern part of the province near the Quebec border and things can be more difficult. But as far as I know, there haven't been ASR issues.
We'll do one final question because I think this is a great question. The question is, do you know if any air was entrained in the concrete for freeze-thaw protection?
That's a great question. I don't know, but I would doubt it. This would have been a very early, 1909, a very early application of concrete in Ontario. One of the first concrete structures actually was the Peterborough lift lock, and that was created at the same time as ACI in 1904. And I'd be surprised if they knew a lot about entraining air at that time.